Number 18, find the Taylor-Maclaurin series. I don't know why the professor put it like that. But anyway, the Taylor series about x is equal to 0 for x plus 1 times e to the x. Find the first four terms in the Taylor expansion about x is equal to 0 for 1 over square of x squared plus 1. These are two different questions in one problem, okay? So let's do the first part first. We're going to find the Taylor series of x plus 1 times e to x, okay? So we're going to use the tactic that we've been doing in the previous problems. If you're following along sequentially, we're going to start with a known Taylor series, e to the x. Hopefully we have that memorized, and we're going to manipulate it until we get x plus 1 times e to x, okay? Now let's go to my PDF version, okay? So e to x is summation as n goes from 0 to infinity, x to n over n factorial, okay? So we just multiply both sides by x plus 1, okay? Now, let's do some simplification, all right? We can move this inside the summation, okay? We can move things out if they don't depend on the index variable, which is n in this case, or we can move it back in if it helps us out. Okay, so I moved it back in this step right here. And then I distributed this x to n to both terms. So it became x to n plus 1 plus x to n, okay? So this is technically correct, but depends how picky your instructor or professor or the grader of this exam or assignment or whatever. Usually the grader is not the same person as the instructor. Sometimes they share the task of grading. Sometimes it's just the grader that does everything. Sometimes it's the TAs. And again, TAs sometimes different from the grader, depends on the school. But anyway, that's beside the point. I'm just going to say grader. Sometimes the grader might be picky and might not accept this because usually pirate series are written in this sort of form. Some coefficient times x to n, okay? This is assuming it's centered at 0, so x minus a to the n, something like that, okay? But hopefully you get the point. It's in this sort of form, coefficient times the power term, okay? Not like this. So let's rewrite it and maybe expand in term by term can help us see the pattern, okay? So that's what I did. So plug in n equals 0, plug in n equals 1, plug in n equals 2. These are the terms, okay? So I started reorganizing, okay? So the whole point is to write it in this sort of form, okay? So we got to be a little smart and try to force this type of pattern, okay? So group all the terms, constants together, group all the x to the first together, group all the x to squareds together, group all the x cubes together, so on and so forth, okay? Because if we want any chance for this form, we got to group like terms, okay? And then I just, for the purpose of combining these two, we want a common denominator. So to go from 1 factorial to 2 factorial, 2 factorial is bigger, right? So it's easier to make this one match that, okay? So we just multiply by 2 on the top and the bottom. Okay. Similarly for this, we multiply by 3 on the top and bottom to get 3 factorial. Okay. And then since they have a common denominator, we can combine. Okay. And then once we do, now this is much easier to write in this type of form. So we get n plus 1 times x to n over n factorial. So this is the quote unquote proper form that you should have. Okay. Again, depends on the grader. They might accept this, but mathematicians that are picky would argue that this is the form that's accepted, generally accepted, the format that's generally accepted. So this is the form. This is the format to get that. Okay. All right. And then the second part, what was the second part again? First four terms in the Taylor expansion about x is equal to 0 for this guy. Okay. So we can either start from something we know. Honestly, I can't think of an easy one off the top of my head to start from. And to be honest, I only have a few memorized for Taylor series. So it might be easier since it's just the first four terms to take derivatives and plug in x is equal to 0. And that'll be it. Okay. Oh, I guess I forgot that I complained that this is a vague question because it just says first four terms, is it first four non-zero terms? Because if we can include zero, you can just see my answer right away, okay? From taking derivatives. If we take the first derivative and plug in zero, we get zero. So if we include zeros, then the first four terms are, we would use these four coefficients. It'll just be 1 minus x minus, or no, it'll be centered at 0, right? So 1 minus x squared over 2 factorial, and that'll be it, actually. Okay? But I'm assuming that this professor wanted first four non-zero terms. So unfortunately, if that's the case, we got to take more derivatives because this term was 0. We can't count that. It's 0 if it's asked for non-zero, right? So you can see how painful this is, but it's doable, okay? So if I'm not going to go over all this clearly. You can check your work if you attempted this, all right? But these are the first four terms where you go through all that painful process, all right? Okay, this just goes to show that as an instructor, it's not the easiest to write clear test instructions and test questions because a lot of times it can be interpreted in different ways. And that's when sometimes students, go try to argue for points and all that, which sometimes it's, to be honest, from my experience, and when I had to do that as a student, a lot of teachers didn't like that. So no excuse to write vague questions then if you don't like students arguing for points from an instructor's point of view, okay? All right, anyway, honestly, if you're a student watching this, I would not worry too much about this second part of the question, but I would understand this first part, all right? This going from e to x to here was quite simple, but I want to impart the concept that if we have to stick to this format that's conventionally accepted, or the convention that's usually people use, then we got to do some additional work. All right. Okay, that's it for this video. Hopefully it was helpful, even though honestly, the second part was not a helpful question, not good practice in my opinion. So just focus on the first part again.